Hello there, we're going to be looking at rational and irrational numbers. This video is specifically made for an introduction into the next topic, which is surds. So after watching this video you may want to have a look at surds. You also, if you're not familiar with converting recurring decimals to fractions, you may want to have a look at that as well. So rational numbers are any number that can be written as a fraction. So examples would be a third, and obviously 0.5 and 0.125, because that would be 1/8, and also recurring decimals. So you'll be familiar maybe that 1/3 is 0.3 recurring. If I take a number like 0.125, and if I put dots above the 1 and the 5, that means that number goes 0.125, 125, 125, 125, and so on. What I can do with that one, just to show you that it can be written as a fraction, is to, first of all, I'm just going to call it x. Pardon me, moving the screen. I'm just going to call it x. And because it's got three numbers that recur, I'm just going to multiply both sides of that by 1000. If it was 2 bits recurring, it'd be 100. If it was 1 bit recurring, it'd be 10. What that does is that turns the right hand side into 125.125.125.125.125. And then what I can do is do 1000x take away x, 999x, and I can do 125.125 recurring, take away 0.125 recurring, leaving me with 125. And then that means if I just divide both sides by 999, I can show that x, the recurring number we started with, can be written as a fraction. So rational numbers can be written as fractions. Now that is a lot of numbers, and in fact is an infinite amount of numbers. If you get as far as university level maths, then you might want to look into the fact that while there are an infinite amount of rational numbers and an infinite amount of irrational numbers, there are more irrational numbers. But I'll let you have a think about that once you've got past this initial stage. So irrational numbers are the rest. Now, for as many irrational numbers as we can, we like to actually give them a letter. So if you take the distance around a circle and divide it by the distance across a circle, you always get the same number. You always get pi. Pi, 3.14159, and so on, is an irrational number because it goes on and on forever with no particular pattern to the decimal numbers that appear in it. They're always discovering slightly more decimal points. E is another example. And that's to do with logs and exponentials. So if you're embarking on C3, Core 3 at A level, then you'll be becoming more familiar with this. And other examples are square roots of numbers. So the square root of 2 is an irrational number. The square root of 8 is an irrational number. And there are many others as well. And what we prefer to do is we prefer, rather than writing it out as the decimal, it's easier to leave it like this because it's more accurate. And that's just a brief introduction to rational and irrational numbers, and in surds we'll be looking at using these rather than writing out the decimals, because it's a more accurate way of doing it. And the manipulation of surds is very important for A level. Also, if you're interested in computer science or maybe sort of data security, then irrational numbers are quite useful for you in the pursuit of that career. See you in surds.